All right, so what we're doing now is we're adding mixed numbers where we have a whole number and a fraction. So if we're adding 1 1/2 to 1 2/3, we're starting to see that these pieces are different sizes. Really what our goal here is to get these circles to be cut down to the same size pieces. So we have 1 1/2 circles here and 1 2/3 circles. Use your imagination. Maybe they're cookies, maybe they're pizzas, you know, whatever it is that you want to add together, perhaps eat. Okay, so our first thing we're looking at over here, and we're realizing that this piece is a half of a circle. Okay, this is a whole circle. So again, the goal is to get the same size pieces. So what I'm going to do here is cut this one in half so that I can start to talk about these pieces as halves. Okay, and really what that's looking like in the math problem would be like this. Okay, you might not actually write it out this way, but you can start to think about it this way, converting mixed numbers into improper fractions. All right, so now we're seeing what this actually looks like. One whole circle is really 2 halves. So if we multiply the 1 by 2 pieces that it's now become and add that to the half that we already had, looking here on the left, we're seeing that we would get, and again, this is quite a bit more steps than we might normally show, but this is 3 halves over here. And if I'm going to do that for this one on the right, let's try to see how me cutting this one whole circle into thirds would play out in the actual math problem. So let's see here. Cutting this, taking my time to do it right. And now we're perhaps checking out the math problem right there, seeing what it looks like when we convert mixed numbers to improper fractions. And we're seeing the slow process of a math teacher turning that mixed number, the 1 2/3 circles, pizza pies, cookies, what have you, into an improper fraction. What is an improper fraction? This is an improper fraction. Okay, we have the 2/3 that were already there, and we have the 3/3. You would call it 3/3. It's a strange way of just saying that there's one whole thing. But we need to do that so again, we're getting the same size pieces. Notice how the 2/3 and the 3/3 add together to make the 5/3. Okay, now it seems like maybe we're doing a lot of extra work to complicate something, but it is a complicated type problem. We have fractions that have 2 different types of denominators. Really thinking about these as cut into 2 different size pieces, halves and thirds. So the next step that we're doing here is we're going to be turning these yellow circles and the orange circles into the same size pieces. So if I see that this was cut in half and this is cut in third, I could just take a couple steps here to get the same size pieces. So if I now take my half and I cut that into thirds, I'm really like multiplying by the other denominator. This is something that people might remember from previous problems like this. I'm gonna do that same thing. And hopefully this long, slow process that I, Mr. Fezzidan, your math teacher, am taking to cut the halves into thirds will help us understand what this step really is. Even the people who have been able to pull this step off and are understanding how to get the right answer, now maybe you're understanding even better why we do this, okay? We're cutting these halves into thirds. And I'm going to do the same thing over here. This will actually be easier. These are already thirds. And I'm going to cut the thirds into halves. It's really like I'm multiplying by the other denominator. But I would have to do that on top and on bottom. So I'm getting all these pieces right here. Pinching these off the floor. Not so easy. That's okay. Don't worry about me. Cut that third in half. And then same thing over here. We had different size pieces, but now maybe while I'm finishing this up, you're starting to realize these are looking like the same size pieces, the orange and the yellow, whether they're cookies, pizza, planets, I don't know, whatever, circular type thing you might be thinking, circular type thing that you might be needing to add together. Okay, so now, couple steps here, making sure that we multiply the numerators by that same number, because again, we were splitting these halves into thirds, and we're splitting the thirds into halves. So now we're looking at pieces that are sixths. Yes, sixths. So it's gonna take me a second here, but I'm gonna take 6 of these pieces and put them back together here to show that it really is one whole. 6 of these make one whole circle. Okay, 2 more. Here we go. All right, how long can we make this video? All right, so yes, that's a 6th right there. And we're gonna get a 6th over here. The orange. Pepperoni pizza, maybe. I don't know. Pumpkin pie. Take your pick. All right, anyhow, yeah, we are dealing with 6th. And we can see we've got the 9/6 over here. Let me bring these back up. And we've got the 10/6 over here. And we're gonna add those all together. Now that we're thinking about these pieces as being sixths, say that 6 times fast. We see that we add all those together. We put all these together, 6 here, 6 over here, and add the extras, and we're gonna get 19, okay? Because we also had the 3 over here. Why don't I just bring these pieces over here to match up with these ones? 3 pieces from the yellow circle over here with the orange circle. Okay. And then all of a sudden I'm realizing that I've got a little bit too much over here. I have more than the 6 pieces needed for the circle. Okay. So as I meticulously, methodically, slowly put this back together, I'm realizing that I actually have an extra piece, an extra 6th. That's okay. When we add all these together, we had what looks like 3 whole circles, sort of, yes. 3 whole circles and 1 extra 6th. Now, this is all nice and fancy maybe, but let's see what this actually looks like when we're solving the problem. Normally, we're not gonna be chopping up circles like this. This is just for us to get the idea, the concept of what is actually happening here with the steps of adding mixed numbers together. Okay, so we have the 19/6. To turn that from an improper fraction back to a mixed number, let's see how that works. The 19 divided by 6 gives us 3. That's the 3 whole circles. The 3 times 6 is 18. It's the 18 pieces right there. We subtract that from 19 and see that there was that 1 extra piece left over. So we put that back together. Maybe this will start to make a little bit more sense now, how we get our answer if we're looking at the circles. I don't know, hopefully, maybe. So we get our 3 whole circles and our 1/6 left over. There's a lot going on right here. Hopefully the pieces help us understand it a little bit better. Some of these steps we'll start to skip. We'll be able to do some mental math in here the more practice we get. But it's really a process now of us figuring out what parts don't I get. Oh, all of it. quote unquote. That's an answer I hear from a lot of students. Okay, what's the first difficult step that you don't quite understand? Let's ask questions. Let's figure this out together. Let's see how we add mixed numbers together by getting the same size pieces and then going back from an improper fraction to a mixed number. Any questions?